Hey TechKnowStuds, in this video, let's talk about network quality. Let's talk about how we would measure that and what would be some of the standards we would look for when it comes to network quality. In this video, let's talk about connection quality. Then we're going to get into some requirements for a couple specific traffic that we would see across our network. And then we'll wrap it up by talking about network delays and what cause network delays. There are a few measurements we use for connection quality. One of those is bandwidth. Another one would be packet loss. There's the delay, and there's also jitter. Bandwidth is measured in bits per second, and that's just the full amount of data that we can get from one point to the other. So how much data can go through this connection? The next one is packet loss. So it's great if we can get data through this connection, but for things like voice over IP, it's really sensitive to packet loss. So let's say we're sending 100 packets from one device to the other, and 10 of those packets were dropped. That means 10 out of 100, we would have a 10% packet loss, which would not be a good packet loss there. The other thing that we have is delay. So when we talk onto one phone, how long does it take for that data to reach the other phone and then to be sent out to the person on the other side? And if that delay is in seconds, that's obviously going to be a problem because I would speak and it would take seconds to get over to the other side, and then they would hear it, and then they would reply, and then it would take seconds to get back to me. And so it creates a whole lot of confusion if we try to talk at the same time, and then we stop talking at the same time, and then we start talking at the same time again, and the delay just causes all sorts of problems with that. Then we have jitter, and that's the consistency in which we can get packets from one location to another. So if we can have a huge amount of bandwidth and there's very little delay to get over to the other side, but then there is delay, but then there isn't delay, then there is delay. That is jitter right there. And jitter can cause problems with things like phones, with your voice conversations as well. So what kind of requirements do we look for when it comes to these connections? Well, first of all, if you're talking about voice, we need at least 30 kilobits per second per line. And it can have no more than 1% loss with that communication. There needs to be a latency no more than 150 milliseconds. That's milliseconds. And the jitter, the max jitter that there can be is 30 milliseconds. So you can see that the tolerance with voice is quite a bit lower than, for instance, data. Data would have much higher tolerances, but it would also depend on what the data is. So there are different types of data that's out there. So it's just not one that we can just classify real easily. But we do say, like websites, the response time needs to be less than a second. Otherwise, you're going to have people that are not going to want to visit your website because of slowness. Video, because it's not only doing audio, but it's doing video as well, has a much higher bandwidth need with it. And then loss, same thing with the loss. It can tolerate a little more latency and a little more jitter with it than just strictly on the voice side of things. So those are some requirements, some targets that we try to reach when it comes to our network. So one of the measurements of quality is how much delay that we have on our network. So what causes delays? Well, one of the things that can happen is we can have bottlenecks. For instance, these are serial connections right here, and they are operating at a much lower bandwidth than anything else on our network here. And so this creates a bottleneck right here of a slower connection, which could be problematic. Another thing that we have is we have aggregation points. This layer 3 switch right here has a lot of devices that are connected to it. And then it gets narrowed down to this one connection right here. So it's kind of a bottleneck as well. But the point is that there's a lot of devices that are connecting into this one connection, into this one spot. And then there's delay points all along the line. So let's take a look at a few of those delay points. Let's talk about delay points. So there's delay points all along the way. And so let's talk about some of those delays that happen. Let's use the analogy of, let's say I'm talking on a software phone on my computer, and I'm speaking to somebody else who has a software phone on their computer. So the first thing is there's some sort of software, some sort of application that's taking my voice and turning it into some sort of digital reproduction of that. So the computer takes that and turns it into a digital stream, and that right there is coding that happens right there. It's an application that's doing that. And that is a fixed length, so it's fairly predictable with how much delay that there is. But bad application would have more delay, and a good application, a well-written application, would have less delay in it. All right, then what happens is then your computer says, okay, I've got the data, now I need to send it across, I need to turn it into a packet. And so it goes through those layers 4, 3, 2. It's got to create the headers for those. It's got to create the trailer for the layer 2. So it's got to create that packet that's going to send. And so that creates a delay right there. So we got packetization delay. Then we've got queuing delay. That packet is sent along the way, and then as it goes into the switch is designed to forward it to only the port that it needs to go out. Well, it's going to queue that up before it can send that out. And there's some sort of queuing delay. And queuing delays can get worse if there's lots of contention on your network. We're going to get quite a bit in depth into queuing in this module. So there's going to be more videos on that. Then there's the serialization, right? And this is when we actually take the packet then and we're converting it into whatever signal is going across that media. So there's going to be a delay with that. So we could have fast connections all along from point A to point B, but there's still going to be a bit of delay because we actually have to convert that into some sort of signal that goes across that line. Then there's the propagation. That's just the time that it takes to traverse that media. Once we've got it into those bits and then we're putting it onto the media, and different media has different rates to it, different theoretical rates and different rates that it can operate at. So copper is going to be a little bit more slow than fiber. Then we have the de-jitter, and that is when that is making it over to the other phone, the packets are not all going to come in at the same time. There's going to be a jitter that's going to happen where it's going to get a few packets, and then it's going to have kind of a time period where it's not getting any packets, and then a few packets again. It's just the nature of how these connections work. And so what the other device on the other side has to do is it has to store up a little bit of these packets before it starts playing it out into something audible that the other person can hear. And so there's a queuing that happens right there to de-jitter that, to make sure that there's a consistent flow. It's similar to buffering that happens when you're watching a video online. It's got a buffer so that way you're not sitting there and watching a little bit and then it stops, and then watching a little bit and then it stops. So these are all delay points that happen when communicating and can cause maybe no one delay there is all that much, but then when it's added up, could be problematic. So in this video, we start out by talking about connection quality. More specifically, some of the measurements when it comes to connection quality. So we talked about bandwidth, we talked about packet loss, delay, and jitter. Then we got into some requirements specifically for voice and video. They have some really stringent requirements because they're very sensitive to packet loss and to those other measurements. Data, not as much usually, although data is a pretty broad term, so it could be sensitive as well. And then we finished it off by talking about how does network delays get into your network.